this assessment, we're asked about the energy that's absorbed by beta carotene in the transition that gives carrots their orange color. Now, because we're given a wavelength of 450 nanometers, we're going to use this version of the energy equation where E equals h times c over lambda. H is Planck's constant, c is the speed of light, and lambda is our wavelength. If we plug in the numbers here, so Planck's constant, we'll write it as 6.63 times 10 to the minus 34 joule seconds. We'll multiply that times 3.0 times 10 to the 8th meters per second, the speed of light, divided by, for at least right now, 450 nanometers. We'll see that we have to change those units to get them to match. We can start by multiplying Planck's constant times the speed of light. You notice that seconds will cancel, so we should end up with units in joule meters. So 1.989 times 10 to the minus 25th joule meters. All of this is going to be divided by what would be 450 nanometers, but because we have meters here, we're going to go ahead and express 450 nanometers in meters. So we'll make that 4.50 times 10 to the minus 7th meters. This is going to allow meters to cancel out so that we end up with an energy that is in joules of 4.42 times 10 to the 19th joules. We made a mistake here. How do we know? That's an important thing. When we plug numbers into equations, we got to make sure that it makes sense. We came up with an answer that is 4.42 times 10 to the 19th joules. That's a ton of energy, right? Do you think carrots, man, if carrots are absorbing that much energy, we should be using carrots to fuel the energy of the world. But of course, we know that's not true. Carrots, in producing their orange color, are absorbing very small amounts of energy in that visible region. Can you imagine if visible light contained 4.42 times 10 to the 19th joules? It's almost comical that that was the answer. So the mistake, we're taking a really small number and dividing it by a number that's larger. We're going to get negative 19 as our exponent. Hopefully you saw that beforehand, but I wanted to leave it there as a mistake because it encourages you think about the answer you're getting and make sure that it makes sense. This answer didn't make any sense. Now it makes a lot of sense. And we've done math correctly.